Hello everyone. Welcome back to our Generative AI series. In our previous lecture, we learned what LangChain is, why it was introduced, and how it simplifies the development of LLM powered applications. We also explored its core components and implemented LangChain in our resume analysis project. At this point, you might have a question. We just learned LangChain, implemented it, and everything seems to work perfectly. If LangChain already provides model, prompt templates, chain, memory, retriever, and tools, then why did the LangChain team introduces another framework called LangGraph? So LangChain is excellent for many AI applications, but as AI applications become more intelligent and agentic, they need capabilities to go beyond a simple sequence of steps. So modern AI systems need to make decisions, repeat tasks, call different tools based on the situation. They'll collaborate with multiple agents together and sometimes even wait for human approval before continuing. Can a simple chain handle all these scenarios? Answer is technically we could hack these together with nested conditions and manual loops in the code. But its scope being a clean chain, you are fighting the framework instead of using it. So here we are not using LangChain, we are just modifying the LangChain here. Okay, so that is how LangGraph came into picture. By the end of this lecture, we'll understand why LangGraph has become the preferred framework for building stateful and agentic AI application. So without any further delay, let's get started. Why do we need LangGraph? Before understanding LangGraph, let's first understand the problem is trying to solve. So LangChain follows a straight line execution model. Each step receives the output from the previous step and passes it to the next step. So one by one step we are going and we are getting the output from one step and we are passing it to the another step. So for example, in our resume analysis project, the workflow looked like something like this. User uploads their resume, they'll extract the text from that, and then we'll retrieve that relevant document from the vector db, and then we'll build a prompt and we'll call the Gemini model, and it will go and generate the response for us. So this is a chain process. There is no mechanism where we'll go and or move backward and repeat previous steps again and again, or dynamically we cannot choose a different path based on the current result. So this part in the form of graph we'll say it is as DAG. So DAG means directed acyclic graph. So here directed means the workflow moves in a specific direction, it will go in one direction. Okay, acyclic means there are no cycle or there is no loops to come back. And graph represents how we are connecting these steps, that is a graph here. So we cannot go or move back, so in a graph term we call it as a DAG. So for many AI application, this will work perfectly. We don't need to change anything. For example, if we want to document summarization, we don't need LangGraph. Language translation, from translating from English to Hindi or English to Kannada, any languages, we don't need any LangGraph. Resume analysis, according to our requirement, we can make it as a loop. If we want to repeat some other steps, we need their loop, but it's not mandatory here. Then for a basic RAG applications also, we don't need the LangGraph. So these applications following a predictable sequence of operations, there is no loop and we don't need to go behind or we don't need to go back. So then in what cases does LangChain becoming limited? Okay, so if now we'll be considering our resume analyzer. Suppose the AI will score the resume, so in out of 100 we are getting 55. Then immediately the result we'll getting it, then we'll hit the our endpoint, we'll get the result from 1 to 10, right? So we'll get that range and we are getting that output. Or in place of that, what we can do is we'll generate a improvement suggestions. it will go and generate a improvement suggestions for us, and then it will reanalyze that updated resume. It will update it and reanalyze that resume, and again it will calculate a new score. Till the time it will do that, it will reach to the desired quality of our resume. So it is going back and reiterating our resume, and again it is checking that what is the score or improvement in our resume we need it here. So this application is repeating the same process multiple times, and we don't know in how many iteration it will be able to figure it out what is the exact resume we need for that particular job. So this requires a loop here. So a traditional chain, whatever we implemented, will not express these things. Okay, these kind of workflows, they cannot be expressed here, but we need to agent go for a loop. So for self review, for example, we need to it to go for the self review. Self review means after writing that answers, it will grade that answers, and again it will go for the loop and improve that answers. Then tool selections. Tool selection mean we are running that, we are giving a prompt and it is running that prompt, or our application, when we are hitting that endpoint, it will run and it is using one or two tools, but according to answer, agent needs more tools to run. So at that point also it needs to go back and decide or pick some other tools as well. So in that case we need the LangGraph. Then write, run and fix loops. So coding agent, what they'll do is they'll write the code, execute it, read that data or trace back that code, and after that it will go and fix the patches, or it will go and fix the bugs for us, and it will repeat until all the test cases whatever we have, we are, when that test cases will pass, till that time it is going in the loop. Okay, so a chain cannot do these things. The chain, we cannot go back and in the loop, because that is a simple chain, it was going in a one direction. So if our application will become more strong, or that is the advanced applications, they require some decision making over there. Loops, they need it. Retry mechanism, we need it. Human approvals, we need it. We need dynamic routing, multiple agents, long running workflows. There are so many things we need it over there. So LangChain will not help us here, it will not go in the loop. So for example, suppose if we are building an AI system for recruitment, so the AI reviews summaries and shortlisted that candidates. Okay, so it shortlisted the candidates for us. Now should it will go and send the invitation immediately. When it will shortlist that candidate, it will go and send the invitations to that candidates using email, or or it will wait for the human approvals. So here the answer is directly we cannot go, because there is a process, at least human we need it to review that emails. Okay, so that shortlisted resume, first it will go to the HR team and they will analyze it, and according to that it will, they'll ask to send email or decline it. So if we'll see here, the process is review resume, it will review the resume, then it will shortlist the candidates, and after shortlist that candidates, it will go for the HR review. Here it will take a pause because it need a human intervention over here. So here humans are in the loop, then it will be the human here, then HR will review that resumes, and then it will ask for send the invite. If they'll approve it, it will send the invite. If they'll decline it, it will got reject here. So this is called a human in the loop, where the workflow pauses until a human makes the final decision. It will not go and work anything till the time human will not say okay you are done. So they require this cycle and chain. Here if we are going with the chain, it will a sequential process, it will not wait. This is exactly the problem LangGraph was created to solve. So here instead of thinking terms of nested if else statement, we think in terms of connected nodes and relationships. Okay, then LangGraph. So LangGraph is an open source framework for creating a stateful and agentic AI workflows. So it's created by the same team behind the LangChain and integrates seamlessly with it. So but it doesn't require LangChain to work it provides a set of tools and libraries which help us to design systems, build and manage AI agent workflows using graph based architecture. So, this is using the graph based architecture model and to manage the relationship between the components. One important thing here to understand is LangGraph is not a replacement of a LangChain because they both are serving a different purposes. For few things we don't need to use the LangGraph. Why will go and create the nodes and make that graphs, right? We just need a simple flow, then we'll go for the LangChain. If few for the few application, if we want to go back and do some another process, or we need to involve the previous step over there, we need to go for the LangGraph. Okay, so LangGraph versus LangChain. So if we'll see here, LangChain means if we'll give some input, it will go for the chain. Maybe there are a step by step process. As we already discussed, we don't need all the components over here. Whatever is needed or whatever is needed according to our requirement, we'll go and use that components. So we'll create a chain here, and at the end we'll get the output. If we'll see for the lang graph means we'll have a input and we have a one step here, and parallelly there two steps are also running. Whatever the output we got from the chain A, we are sending it to the chain B and chain C, and they are working in a parallel. So here what the output we got from here, that is till here, and it is also stored and saved. Okay, and at the end we are getting the output. In LangChain, we have to go steps and steps, and we take input from one step and send it to the next step. In LangGraph, we have flexible workflows with branching and parallel steps. This will help us in the complex decision making app. So now we'll see the LangGraph versus LangChain. So if we'll see the architecture in the LangGraph, that is a graph based architecture where we'll have nodes and edges with they'll have memory as well, and they are in the branches. We already know about that, right? And the LangChain means this is a sequential decision act loop. So we are going in a sequence and there is a no back from here. And then if we'll talk about the workflow control, this is a fully customizable path. We can customize it according to our requirement, and we can loop it, and we can mention the conditions as well. That's why we are using the LangGraph. And in LangChain, this is a limited control. If we created a sequence, it will go that sequence one by one. We don't have any control over here, and it will just follow the predefined tools. Okay, so we are already defined that tools, it will go and uses that tools. And then state management. So state management means LangGraph is maintaining a single shared state that every node can read and update throughout the workflow. And if we'll talk about the LangChain typically have to pass the data manually between steps, or we have to manage it using the external memory or some custom codes. That's what it mentioned here, right? Implicit or external memory required. So we have to manage it. It has the built-in persistent state across the entire graph, so we don't need to manually manage it. Then support for loops. So if we already understood this, yes, it will support the cyclic flows and iterations. Now this is not designed for the loops or retries, it will go sequentially. Then human in the loop, this is supporting that if any human intervention is needed, it will pause for a time till the time it is not getting the response back from the humans, and it will resume with human input. And this requires custom implementation if we want human in the loop. Then debugging and observability, high observability with tools like LangSmith. So it is using the LangSmith as well. It is has a limited transparency, and it is harder to debug these kind of things. Okay, so today we understood why LangGraph was introduced and what limitations it solves. We learned that while LangChain is excellent for sequential workflows, modern AI application often requires decision-making loops, retries, dynamic routing, human approvals, and multi-agent collaboration. So there are so many things we need in between to complete that process or flow. Managing these scenarios using traditional chains, this will quickly become difficult. So that's why LangGraph provide a graph based execution model that is more flexible, scalable and suitable for building intelligent AI systems. In the next lecture, we'll deep dive into the core components of the LangGraph. We'll understand concepts such as state, nodes, edge, start end and conditional edges, and see how they work together to build powerful AI workflows. Until next time, keep learning, keep building, and keep growing. I'll see you in the next lecture. Thank you.